actually wish you'd come down here. Come closer. Some of you, at least. I know it's a huge room, but if you're going to be able to talk and ask questions, yeah, somebody's getting up and moving. That's excellent. So today, this session, we're going to have 3 presentations, topics that all have to do with working very hands-on with things that relate to security and privacy. If you were here for the plenary session this morning, you heard Jake talk about Tor, and one of the presentations today is a project that has to do with privacy preserving something else, and that is data storage. Christelle is going to talk to us about that. We're going to have right now one of my colleagues talking about the social CERT, and then finally we're going to wrap it all up with a presentation about VoIP security. So, with that, Johan, take it away.
Is this? Yes, this is on. All right. They got us the smallest room in town, right? Huge. Right, so my name is Johan Bergen. I work at Nordernet. And I'm going to talk about social CERT and a little bit what we mean about that, what we are trying to do with it, and then I'm going to present a tool that addresses some of the challenges that we see in this area. So I'm going to start off by talking about what the CERT is. And I guess that most of you know what the CERT is, but it stands for Computer Emergency Response Team. And it's an organization that takes care of the abuse handling, the incidents, and all that stuff in the organization. And the challenges that we see in our community, in the R&E community, are our incidents are almost always at a global scale, right? So they have a really big impact on when they do occur. And it's very difficult to coordinate our efforts. And this is because our community are very agile. We are working in different organizations. We have virtual organizations that do this. We have researchers floating around between organizations and have accounts all over the place. And this makes our life as incident responders very hard, but it's necessary for us to do our research. So what are we trying to protect? We are trying to protect, of course, we are trying to protect our users, our end users. They need to do their stuff, they need to do their research, they need to do their jobs. So we want to protect them, we don't want to protect the resources that they are using, the computer systems and all that. But we also want to protect the rest of the world from ourselves. And that's not that our users are evil or bad, but because it's very common that the users got infected computers with malware or viruses and that are attacking the world, and we want to protect them from that. But we also want to protect a free and open internet, and this is very important because that's what our research, right, is foundation for the stuff that we are doing, for all the research that we are doing, all the innovation that we are creating in our community are based on an open and free internet. And we as security organization and incident handlers and so on, we need to do our job good to protect this. Because otherwise we will have a more filtered internet and a more harder to access internet, and that is a bad thing for us. Right, so the challenge, and this is just one of the challenges. There are a lot of challenges in our community and what we are doing, but one of the challenges is that we don't want to rely on IP addresses to solve crime, basically. The bit that is communication in an investigation, one of those bits are communication part, but it's just one bit of it, just one piece of the puzzle, and we don't always have that. And as Jacob told us earlier today, right, we have the right to be anonymous on the internet, and we should be able to be that. We should be able to preserve our privacy and for doing our research. And so we don't always have it, so don't rely on it. We cannot rely so hard on that bit, on that piece on the puzzle, right? So And the thing that this creates, it tends to create, is more need for data retention. And this is bad for a lot of reasons, but the trend is going right now is that we need to store more data about our users and the communications that our users are doing in order to solve crimes, right? So this is bad for the privacy of our users, and we want to protect that, as I said earlier. So this is the challenge, and I'm not so fond of just saying that this is bad, right? I want to have a good alternative. How can we solve this in other ways? So what can we do? Well, we can be more social, and importantly, be more transparent. More transparency in our business and in the security business is extremely important. Transparency between our community and the government CERTs and the private sector are extremely important to gather other bits of information, pieces of information to this big puzzle when we are doing our investigations. So by sharing this non-sensitive and information and data, and that is data that's not bound to our users, not privacy invading for them, but by sharing this data about the little slice of internet that we are handling, we can actually build a bigger picture and have a lot of good data to work with when we are trying to solve our investigations. And one of the most important aspects of this is that we are creating pointers to who can I talk to, right? And has anyone else done anything in this area if I'm working on a case for a specific kind of malware, for example? And sure, we are doing this today. We are using mailing lists and secret handshakes and secret meetings, of course, and we're doing a lot of collaboration already today, but we can do more, and we can be more proactive. So just to give you an example, and this is from our very tightly from our communities, is supercomputers. We have a lot of supercomputer centers out there spread all around the globe, and these are popular targets, right? In the old times, it was the bandwidth they wanted. They wanted the computing resources and so on. But that's maybe not that important today for the attackers, but it still gets some credits to hack us, and they are doing it. So what they are basically always doing is they stole accounts, and they steal accounts, and stolen accounts get spreads across organization. As I told you earlier, our researchers are floating around. So a stolen identity, a stolen identity here will spread to other organizations, to other countries, to other supercomputer centers, and we have a whole lot of mess. And I've done a couple of these large investigations, and it's really hard. And communication is hard, and communicated with my fellow investigators in other countries is always really hard, right? So. One of the investigations, I've actually sat two nights and was backtracing an attack and trying to understand the attacker, trying to reverse engineer what the stuff that he was doing, and I finally cracked it, right? But just the day after, I realized that one of my colleagues in another country had already done this job, so I had basically could have saved 2 days of 2 nights of work just if I knew that, right? So this is where I began to think about we need to create something. We need to do something more than having the mailing lists and having all of that. We need something more. We need to be more proactive instead of just reacting on the incident that comes, right? So the tool is called ForDrop, and it was born out of the frustration about this. So I was really frustrated. So what is ForDrop? And this is the tool that I'm presenting here. ForDrop stands for Forensic Dropbox, and it comes from the time I was analyzing malware and binaries, and I wanted to share that information with my fellow investigators. So it's a system for sharing information about malware, for example, and other reports in an investigation, and then you add the social layer on top of this. So you add comments and tags, as we know from other areas, but you add that to this as a human-generated metadata kind of thing on top of the malware findings that you do, and share that with your fellow investigators. And this is very powerful because then you can start to see connections with things. So it becomes a kind of crowdsourcing for IT investigators or forensics. ForDrop is open source. We believe in that, and we want to build stuff on top of open standards, so we are doing that. We are using modern web technologies, and together with a very powerful federated backend, right? So, because one of the very important design decisions when we started this project was this shouldn't be centralized, this should be decentralized. We don't want to build yet another silo where we collect all the information and we promise you guys that I will not share this with anyone else than you tell me to, right? And we don't want that. We don't want a system like that. We want a decentralized system and a distributed system for doing this. So what are the technologies that we are using? Well, the backend that I was talking about is XMPP, and I'm sure a lot of you know what it is, and most of you maybe know it by the name of Jabber. It's used mainly for instant messaging and one-to-one chats and group chats with others. But it has a couple of things that are really nice and that we have used in this project. And the X in XMPP stands for extensible, and that is one of the things that we are using, right? So, and I'll come to that later on here, but I said that it was federated, and how do you build a distributed model? How do you build a decentralized system for sharing information in a secure manner? Well, in XMPP, we have federation built in, so you're able to, with your XMPP system, you're able to talk to other XMPP systems and in other domains. That is built into the system, right? So when a user uses one system in, for example, fordrop.org domain, want to talk to someone in example.com domain, the XMPP service will start talking to each other and federate in that way. So we are using that extensively in ForDrop for a way of deploying your own installation of this and controlling your own data, right? Then we used an extension called SEP 60, which is a publish and subscribe system. It's a classic publish and subscribe system where you as a publisher, you as a user can publish information on a node in your XMPP server, right? And that information will get pushed out and fanned out to all of the subscribers, all of the other users that you have a relationship with that have subscribed to these nodes. They will get that information pushed to them in real time, and we are using that. But we needed something, and that is fine, right? So we have that, but we needed to be able to control this in some manner. Of course, you are possible to create a public node and a world-readable node where anyone can subscribe, and you can do that. That's fine, but we needed, in a lot of ways, we needed the possibility to control access to these nodes. So what we do in ForDrop by default is creating closed nodes, so no one can actually subscribe to them. And then we are building a management layer on top of this. And this is what is actually lacking a lot in XMPP. We don't have any good management tools for handling XMPP pub/sub. So we built that, and what we needed to do was to be able to create nodes and create nodes with default configurations. We must be able to manage the access control to these nodes. And then we want to be able to, and by doing this, we are establishing peerings with other systems. So how do we do this? Well, you can do it in a lot of ways, right? You can do it with plain XMPP. You can talk XMPP directly to XMPP server and do all of this stuff. It's all built in. It's nothing special, but it's quite hard to get into that. So we built and quite hard to integrate that into a lot of other systems. So we created a couple of ways to do this. One of them are we have a JavaScript-based management tool which we are incorporating into a web-based front end for this. As I will show you that in a couple of slides. And then we have a ForDrop REST server. We created and this was a demand from from one of the guys that wanted to integrate ForDrop into a product of his, and he didn't have the possibility to do XMPP directly. So I asked him if it would be possible to do HTTP, and with the RESTful API, could you do that? And he was glad about it. So I created it, we created it, and so we have that. We have a REST server so going over HTTP with a RESTful API where you can manage all of your pub/sub operations. And together with this, we have some simple Python libraries that you can use. So this is just an example of what you can do with this API and how simple it is. And with the help of this, we have created just as an example, a CLI client. So everything you can do with the JavaScript client, everything you can do with the API, we can do with this CLI client. So you can integrate this into command line tools or tools that are run in the console. This is nice. You can add nodes, create nodes, manage your affiliations, manage the whitelists on these nodes. Right, so now we have the foundation, right? So we have the federation part, we have the messaging passing between systems, we have this information sharing peering set up, we have the possibility to do this. Now we need to understand each other, so we need a format to put into the XMPP messages that we are sending out. And we can just invent something ourselves. That wouldn't be any problem. But we wanted to use something that were actually there and that folks were using. So we looked at activity streams, which is it's a specification for, it outlines the details and the serialization of stream of social activities, basically. And it's an example of that is Johan here. I think yes, I have an example here. Johan is posting this photo to a photo album, right? So Johan is the actor here, and post is the verb that we are performing, and then we have an item and a target. And we are using this in ForDrop to represent the different things and actions that we are doing and activities that we are doing. And this was created by the big giants, Google, Microsoft, MySpace, or Facebook, and others, in a way for them to start interop some and do stuff together and simple mashups and stuff like that. So what we are doing in activity streams in ForDrop, you're able to post information about, for example, a file or a binary. We compute. You don't actually share the binary or the evidence directly. You share the reference of it, right? So you create the hashes of it. You create maybe a fuzzy hash of it to be able to compare it to other things, and then you share that to the peers that you choose, right? You can comment on it, you can tag it, and you can group tags to create ForDrop collections, which is just a collection of tags that are tracking a number of objects, and that is a collection is like an investigation, and then you can share that investigation with others, so others can input data into that collection, and in that way you're creating a collaborative investigation, which is very powerful. So integration, and I talked about it, but we wanted to be able to integrate ForDrop into current workflows. So we don't want to replace anything. We don't want to build a system that does everything. We just want to do a little piece of this that is the sharing of information. We want to hook this into your current workflows, your current tool sets that you are using, and having this as a platform for distributing the information and sharing the information and doing all of that. And hopefully ForDrop makes this easy and fun. It should be fun to do this. Otherwise, we won't do it. Right, so fordropweb. So we have the foundation here. We have all the pieces that we need. We have a format that we can talk so we understand each other. Now we need a way to consume this and also produce data into this. So one way is to integrate this into tools, but another way is to consume and produce stuff via, for example, a web UI. And we have created that. And it's more than a web UI. It's actually a decentralized social web thing that you can install yourself, host yourself, and control your own data. You don't rely on anyone setting that up for you. You are setting it up yourself. You are hosting your data, and then you decide what to share with whom over XMPP pub/sub. So this is, I throw in some screenshots here of how it looks, and we have try to build a nice looking web interface for this and a website for it, where you can share, you can comment, and you can tag all that we are used to. Create these collaborative timelines, for example, and all the stuff that you put into a collection or an investigation generates a timeline where you can add stuff into an investigation. You can follow what happens when, and so on and so forth. So this is a screenshot of how you can manage your federation. And this is the drag and drop interface. So this is an XMPP pub sub management tool written entirely in JavaScript. So you can, and this is very much like Google Circus, if any one of you have used that. So down here at the bottom, you have some nodes, and up there you have your connections. I just have one friend here, but and then you can drag and drop those into these nodes, and effectively making it possible for them to subscribe to that node. So, summary. Transparency and collaboration are really, really important, and that's what we are need to do to be able to, take the communication part out. Don't rely on IP numbers. Don't rely on the communication between A and B, right? If you don't have that, screw that, and go with the other pieces of the puzzle that you have there. And by using a system like this, and by collaborating and talking to each other, we can actually start being more proactive instead of reactive, and use the time slots in between the investigations, in between these big fires when all of us are in panic, right? So use those slots and put in information into this and share this with others. I think that will benefit us. So that we are trying to build a platform to do this, and to make it easy to do this. So the development, how are we doing this? Well, we got funding from .se, which is the Internet Infrastructure Foundation in Sweden. They give out money to projects that they think benefits the internet, and we got a bunch of money from them, which is really nice, and that made it possible for us to create this. It's open source BSD license to basically take the code and do whatever you like with it. And it's up on GitHub, and you can follow the development there. We are doing it all transparently and open. Security should be done that way, I think. You can find more information at fordrop.org, and we will update that when there are more information or new information about the system. So you can follow that. You will also get pointers to the GitHub repositories and other stuff there. Questions? Right?
So if there are no other questions, I will ask you a question. So you mentioned integrations. Can you give a couple of examples of systems that you are integrating with right now?
Right. So we are working with a couple of systems, and one of those are called a network.
So these are basically NDS intrusion detection toolkits, basically?
Yes, exactly. And it's a wireless network detection system where they are collecting malware samples from the wireless network, floating around and a forensic tools for that. And we are integrating that tool with ForDrop to be able to, when you are finding stuff with that tool, you should be able to post them to ForDrop, post them to the nodes that you selected in the tool, and that will get pushed out to them. So that is a really interesting integration. Then we are also working on integration with a tool called CuckooBox, which is a whole framework for forensics that creates VMware images for you, and they are injecting malware into the images and analyzing it, and then you will be able to pull the results from that and push that to ForDrop and share it with ForDrop. So we have a couple of very interesting integration projects going on.
Thank you. Right. If there are no other questions, let's thank you all. And it's time for Christelle to come up and speak. And Christelle is going to talk to us about something called the Tamias project, which is some form of squirrel, as far as I understand. And I'm sure Christelle will explain to us exactly what the squirrel reference is. It's always interesting to see what people do with their microphones.
Thank you, Leif. So I'll talk about Tamias, which is a distributed storage that is built on privacy and identity. So this has been done mostly with my colleagues at IIJ, and also Leif, who gave us a lot of advice. So I'll explain why the chipmunk later. So today, users have a lot of data, and they have two ways to deal with it. Either they store it at home or in clouds. And usually, sometimes they may use more than one cloud because they try to benefit from free solutions. But these free solutions, in fact, have a drawback. They're not really free. The cloud providers use users' information to build profiles and sell these profiles to advertisers. So what we believe is that the future is not in cloud storage, but in collaborative storage, where users have their own storage in their home, and they collaborate with other people that they know that also have storage in their home to split the data on multiple devices, so which makes the data resilient. So if users use collaborative storage, they would encrypt their data in the different boxes in different people's home to make sure that the people who manage the boxes cannot have access to the data. So we believe that user privacy is very important. So what are our requirements? Our requirements are the following: scalability and resiliency. And for this, we rely on distribution. So we rely on a distributed storage, so peer-to-peer-based store, and we rely on capability-based access control, so which is completely distributed. The storage nodes each perform authorization. Then one of our requirements is privacy. So the data of a user never leave the user's device without being encrypted. Then finally, we want a solution where users can share their data with other people. We want fine-grained sharing, so users, when they share information with someone, they share it with that person and nobody else. So the focus of this work is how to ensure this fine-grained sharing, and this relies on identity and scoping of capabilities based on the identity. And we want still to have the property of traditional capabilities, that is completely distributed access control. So why do we need identity? We need identity because we need ownership for the data. We need to be able to say, this person shares this information with that person. So we store the identity next to the content of the identity of a person next to its content, and the capabilities are scoped because they are initiated by someone for someone. So here I'll talk about identity, which we enforce using asymmetric keys, secure sharing with the scoping of capabilities and block ownership, and finally self-introduction. So self-introduction could be done out of band, which is more secure, but we also provide an in-band mechanism, which is better for the users, which is more usable. So this relies on the phone book and messaging system. So the identity in Tamias is a pair of asymmetric keys. What are the implications of this? It is hard if we do in-band introduction. It's hard to make sure that the person is really the person that it pretends to be. And then it's also hard to verify that a person really gives its public key and not the public key of someone else. Apart from that, because the identity of a person is its public key, we don't need a secure channel to exchange that information, but it's very hard to handle public keys by humans. So, introducing this concept of identity allows the following applications. A user can use the system to store its own data and to not share the data. So I store my information there and I want to retrieve it later. Or a person can use it to share content with other people. So for picture sharing, calendar sharing, for example. It can also be used for pseudo-anonymous publication. And this is because of the implication that we have with in-band introduction. So if we are never sure that if we can never link a person, a physical person to the identity in the system, then in fact, a person could create an identity to publish information and share this information with journalists. And this way, remain anonymous. But still, the journalist will be sure that it's always the same identity, so it's always the same person sending the information, but the journalist doesn't know who it is, so he doesn't have to really protect its source, he doesn't know who it is. And then, because we have this notion of identity, we can do third-party introduction. We can talk about other users. For example, here, Alice knows Chris and Bob, and she wants to tell Bob that Chris is a trustable person. Because we have identities, we can talk about people. So, capabilities today have limitations, and the limitations are that capability is usually a key to decrypt the information and a map, so a place where the information can be retrieved. And based on these two information, you can retrieve the data and decrypt the data. So which means that if I give a capability to someone, that person can give it to anybody, and anybody can access the content. So it's the same if I give a key and a map to my apartment to someone, that person can find my apartment, but can also give it to somebody else that can find my apartment and enter. So scoped capabilities is generating a capability for a given destination, a given person. So it's like having a key, a map, and then a personal code or fingerprint. Only the person whom I intend to access my apartment will be able to enter my apartment. So in Tamias, scoped capabilities look like this. It's three major sections: the authorization part, the signature part, and then some metadata. And the authorization contains information about the file, which is used by the destination to decrypt the file. So this file information will be encrypted with the destination's public key. Then we have the notion of owner, that is the public key of the owner of the content. We have a storage index, that's where in the system is the file stored, or blocks of the file stored. And then the target user, that's the public key of the user with whom I intend to share the data. And then the validity period for the capability. Then the signature is a signature over a hash of the authorization section, and it's signed by the owner's private key. And the metadata can be anything, like the file name and some tags, to be able to later do searches in the system. So this graph shows how authentication and authorization is performed. So here we have Alice that shares some content with Bob, and then Bob wants to access Alice's content. The Alice content will be split on multiple nodes and stored on multiple nodes, and Bob has to contact each of these nodes to retrieve the pieces of information. So Bob will perform some authentication and authorization on each of these storage nodes. And it will first request a nonce from the storage node. The storage node will reply with a nonce. Then Bob's client will sign the nonce with its private key, will send its public key and also the scope capability. And based on this information, the storage node is able to say, okay, this is really Bob because Bob's signed the nonce, and this is really an action that Alice allowed Bob to do because of the scope capability. So the result is sent to Bob's client, and based on this, the storage node will also send or not send the blocks, the content blocks. So these authenticated capabilities enable a user to access its own file, but also enable delegated access control and per identity revocation. So with capabilities as there were before, when we store content in the system, if the capability is spread outside our means, the only way to revoke access was to remove the file, but now we can revoke capabilities. So now I will explain how self-introduction is performed. This is an alternative to out-of-band self-introduction. And we rely on three mechanisms: a conversation box, a public inbox, and the phone book. So there are multiple conversation boxes. They are used for private communication. So if Bob agrees that Alice shares information with him, Bob will create a conversation box. And in the conversation box, Alice will store statements saying that she shares content with Bob. And she may also there store statements revoking access to some content, or telling Bob that she trusts someone, for example. The public inbox is used to discover the conversation box of a user. So when Alice wants to share information with Bob, Alice will try to find Bob's public inbox, and in the public inbox, Alice will store information on her conversation box, such that we can start the notification of file sharing. And then the phone book is used to discover the public inbox and the identity of users, so the public key of users. So Alice, when she wants to discover Bob, she will look in the phone book. Based on information that she knows about Bob, she will be able to find Bob's public key and Bob's public inbox. And these mechanisms, the phone book and the public inbox, and the fact that you publish information about yourself is really not mandatory. This is if you want to perform in-band self-introduction, then you may need this. But if you want to do it out of band, you don't have to advertise anything about yourself. So if you want to keep it really private, you don't have to participate to this. So to summarize, Tamias provides identity, fine-grained sharing, and user self-introduction for distributed storage systems. And Tamias relies on Tahoe Labs, which is a collaborative distributed storage system that makes use of erasure coding. So splits the content into multiple blocks, and you retrieve only a few of them to reconstruct the full content. And in Tahoe Labs, the data is directly encrypted on the client's device, so you don't need to trust the storage providers, so you don't need to trust the people in your collaborative system to store data at their place. They are not able to see the data. So by relying on a system like this and adding identity, fine-grained sharing, and self-introduction, we have something that is usable, we think, and enforces users' privacy. So if you want to have more information, the project webpage is there, and Tahoe Labs project page is also there, and you're welcome to ask me questions.
Yeah, and I think it's a very interesting system. One thing I was thinking is if you So you announce for your identity where your public inbox is so that people can send you messages, right? So with that, you're publicly announcing something that everybody can see. Wouldn't that, doesn't that give up, for instance, maybe somebody can analyze the traffic and see somebody's writing to us. I guess this public inbox is like an append-only folder where you can append stuff, but you cannot read it back.
Yes.
But maybe you can see if somebody is writing to that key, then you know that somebody from that IP address, you don't know the sender address, but you know that somebody from some IP address is sending messages to that user address, and you, isn't that a problem?
I don't think so. So the public inbox is an object stored in Tamias, and so the public inbox, the thing we publish about the public inbox is where is the public inbox. So you will be able to find on which storage nodes it is, and if you don't, because it's distributed, if you are not able to monitor all the storage nodes, you will not be able to sniff the.
Okay.
And also it's encrypted from the client device. So if I want to store something in the public inbox of Leif, it's encrypted as soon as it leaves my machine, and then it will go to different.
Yeah. And one other question with Tahoe, I think the main issue is always freeloading, and the fact that you're pooling resources. So you're probably, if you would do this in an NRAN, then you say every university would have to run a node, and then altogether we are a distributed storage with all the universities of one country, for instance. But then if you start to federate that and make it bigger, then the resource, the people paying for the resources are more and more decoupled from the people using the resources.
So we didn't implement this yet, but our objective is to have multiple domains. So one university could be, or one university could be one domain, and then another university, another domain. If you're a member of that university, your data would stay on these servers, and people of different universities could access your content that would stay on the home university.
Right, yeah. I think that's a good choice, yeah. Thank you.
Anything else? So, can you tell us a little bit about your sort of the timeline for your project? You're talking about possibly some testing right now, or whereabouts are you at?
So now we have a release that contains everything except the phone book yet, and this summer we'll have a student working on a deployment. So we just ordered 15 boxes that we will install and deploy and do some measurements to see how scalable it is and how fast you can get the information. And after this, we plan to have an API such that people can implement applications on top of this. Because now it's just file sharing, but we want to have calendar sharing and more high-level applications later on.
I'm looking really forward to that. It'll be cool to play with.
Thank you.
Oh, there's another question, I think.
How would you support? Annie, yeah. How would you support the project work and share the development of documents and updating common documents? Is that possible with the framework, or is it possible to extend it?
Can you repeat the question, please? I didn't.
So how would you support project work in which case many persons share the same data and want to update it?
So at the moment, it's only one owner of for a given file, and we have thought about having groups, but this is not finalized yet. So if you would want multiple people, well, okay. yeah, if you want multiple people to work on the same file, it's possible because you can give read and write access to a file. But at the moment, the owner is an identity in the system. This identity can be a person, could be a person responsible for a group, but it doesn't go farther than this. Does this answer your question?
I'm trying to scan the audience. You seem satisfied. Right? Oh, there is a question. Just really difficult to see for the lights. I'm sorry.
By answering one of the questions, you stated that if, for instance, I would store a file, the file or the data would only be stored at my university. That's correct?
Well, it depends how you want to deploy it, but that's one possible way of deploying it. You could have, in a university, you could have a data center with multiple storage nodes, and then provide this for your students as a service. The current model is you have boxes at home, and geeks play together and in one domain. But later on, well, I work for an ISP, and so we thought about this model where the ISP would provide, for people who don't want to have their devices at home, would provide the storage system for the users. And this is applicable to universities as well.
Okay. Yeah, I think for resilience, it's much better to spread the data. And if it's just in one country, I think nobody will have any problems with that. And this protocol is in particular very nice and well performant if you spread all the data.
Yes.
Then if one university goes down, you can still reach your data. That would be very nice.
So you could, if you have agreements, multiple universities over multiple countries, you could, for example, build one bigger domain. But this really depends on how you get along.
Okay, thank you.
Just to respond to that, I think I think both points are important. So you want to spread everything so that it's resilient, but you also want to be able to bill resources to people who used it, I think, to stop freeloading. So maybe one thing you could do is keep track of which university is using a lot of resources, so that at least you know who is using up the resources, and then you can still spread it around everywhere, and then but you can have a free market of storage space, and then you can even connect all of Europe, but know that the University of Verona is using up a lot of space, and then you can at least fight freeloading and at the same time still have resilience, I think.
So because we have this notion of ownership next to the content, we know whom the data belongs to. So we can also clean the data afterwards if students, for example, leave the university. And if you know, based on an identity, if you can know to which university that person belongs, you can sum up the university consumption. But if you need something smarter than this, to be able to prevent a university to use more than a given amount, how to balance between users is something we didn't really think about yet.
No, I think in itself, the ability to clean up and to know who is using resources is already a big addition to Tahoe, even if you're not even looking at what you can do with the message send. So I think that's really good.
Thank you.
All right. Thank you, Krista.
Thank you.
So, our next speaker, Jakub Szafarik from CESNET. I always mispronounce CESNET. Sometimes I say Chesnet, but it's CESNET. And he's going to talk to us about the security of voice over IP systems, which is quite an interesting topic. Thank you. Take it away, Jakub.
Good afternoon. My name is Jakub Szafarik, and I would talk about some security tools for voice over IP systems. And I must mention that all these systems were developed in projects by CESNET organization. So voice over IP is nowadays one of typical services. With this situation, there is also a higher malicious activity in voice over IP, and this leads to frauds and attacks in IP telephony. A good way for probing protection level of server is a penetration test. So, SIP server is a key element of voice over IP. If SIP server goes down, our whole communication is affected, and now there is no user who can communicate. So there is also many monitoring and testing application, but these applications are typically quite widespread, and they are not oriented right on voice over IP. So there is no complex tool for voice over IP testing. And this is the motivation for SPT, which is application for complex penetration test on SIP servers. And even if you know about security risk on your server, you still need some tool which can automatically defend the server in case of attack. And this functionality can be achieved with intrusion prevention systems. SPT is it is our complex tool for VoIP server security testing. It's a web application, so you can log in if you have the rights and run different type of tests against voice PBX. Important fact is that you don't really need run SPT in your inner network like many other security tools. It can run outside the network, and it tries to simulate a real attack on the network. So there is some information gathering and then various type of attacks. Results from the test are shown in the web application and also sent via email to the tester, so he can analyze it later. I forgot to say that SPT is built from modules, and each module is for a different type of attack. So let's start with first module. It's a scanning and monitoring module. And it tries to simulate a real information gathering from a potential attacker. So there is some scanning for open port, running PBX software, version of the software, SIP accounts, and password to these accounts. There exist many applications which have this functionality, and we choose to use Nmap and SIP wishes. And this module also saves the gathered information for further use in other modules. Denial of service module. As is obvious from its name, it's a module for sending DOS attack on the SIP server. DOS attack means flooding server with large volume of adjusted or malformed packets. And for this purpose, we use UDP flat and invite flat application. I will also talk about denial of service later. Now, how the denial of service module works. It starts first with measuring average response time of ICMP request on target server, and then the attack starts, and then is another ICMP measurements during the DOS attack. So if the average time during the attack, average response time during the denial of service attack is at least 150 times greater than average response time before test, the whole test is marked as successful. Otherwise, the test failed. Registration manipulation module tests server robustness against attacks which aim to manipulate registration. These type of attacks can be easily expanded to popular man-in-the-middle attack. So we use application reg hijacker, which switch one of legitimate accounts with another fake one. The tester must input in the system some valid account and password, or can use just the information from the scanning and monitoring module. How work the registration manipulation module? SPT sent attack message, do the registration manipulation attack, and then just send SIP invite request on target PBX. And once the message is sent, it waits on response from the target server. If the response is 180 ringing, it means that the manipulation wasn't successful and server protection is good. In case of answer 503, service unavailable, the attack was successful. Last module of SPT is SPID module, and SPID is an voice over IP analogy to spam in emails. So it is typically unwanted calls with commercial content. For this type of attack, we use SPID file, and that's our previously developed application which plays the SPID calls. This application uses stolen accounts for placing calls on registered accounts in the target network. It works in a way that SPT sent 5 SPID calls on target PBX, and again monitor the responses from the target. And if the answers are all 5 responses from server must be 180 ringing. In that case, attack is successful, otherwise was not successful. So these are the basic modules of SPT, and a result from this application is not only analysis of individual attacks, but part of the result is also some methods how to limit or completely mitigate potential security risks. And the result is also sent to email to the tester. Time requirements for a whole bunch of tests depends on many factors, typically on use models or variables from the tester. So now I would talk about intrusion prevention system, but before I must mention BESIP, because intrusion prevention system is part of this solution. BESIP is our embedded SIP communication server. It's a solution for IP telephony. It is multi-platform, modular, variable, and with simple configuration. We prepare a version containing both hardware and software with a cost about 200 euros. So it is cheap, and you can buy it for your needs. You can use it at homes or in detached workplaces or small offices. The system has a simple configuration. It is possible to configure it through a web interface, but it is fully configurable through netconf, which gives us a general mechanism how to fully configure all the modules. There are modules for monitoring, security, speech quality, and all solution runs on Linux. We use distribution OpenVRT, and you can choose from 2 software PBX. One is Asterisk, and the other is Camelio. The project is still under development, and you can download a VMware image on the web pages below. So intrusion prevention system, it is a system for automatic blocking of malicious activity in a network. It is no surprise that it's also based on open source application, and the core of intrusion prevention system is intrusion detection system SNORT, which is very popular. And ability to dynamically block IP addresses give us application SNORT-SAM, which can dynamically change rules in firewall. And IP tables are kernel Linux firewall, which we use in BESIP. We discovered that SIP servers are very fragile against those attacks. The impact of attack is even bigger when you run the SIP server on limited machine like BESIP. So denial of service can be sorted in two groups, intentional and unintentional, where belongs crowd frenzy or some configuration mistakes. But we focus on intentional attacks, which aims right on the server. And the most typical are depletion attacks, which aims on consuming server's physical resources like CPU, memory, or link bandwidth. There are also some misuse DOS attacks, and these attacks typically use some concrete flaw or buffer overflow or protocol deviation, but we want some general mechanism that we are not bind to some specific software PBX version. Here is an example of flooding a server with different SIP messages, and it is quite a low rate. In a real attack, the rates are really high, but we want to show influence of different SIP messages. The attack starts at 10 seconds and then lasts for 50 seconds. So the last 30 seconds show us a server recovery after attack. And we can easily see that the most dangerous attacks are flooding a server with register messages, which is the red color, and also flooding with options messages, which is the blue color. In those two cases, SIP server was unable to serve new calls, and even current calls were disrupted because they were routed through the PBX. Yellow shows us invite message flooding, and because the sending rate of the attack was really low, the server was not so affected as in register flood, and was still able to serve calls, and current calls were not affected. There are also, we try to flood the server with buy, acknowledge, and cancel messages, but that represent a real threat for the server on small rates, and all the was very similar like by attack, and on high rates the attack is more like flooding the server with UDP packets. So how this situation change with an IPS system? Again, blue line is register flooding without active IPS mechanism, and green color show us the same situation, same attack, but in this time the intrusion prevention mechanism successfully stopped the attack, so the communication was not affected, users can place call, and attack was successfully mitigated. We also try another attacks like UDP flooding. And in this case, because the intrusion prevention mechanism and firewall is on the same machine, it's not possible to block UDP flood right on the server. because UDP flooding aims to consume link bandwidth, through which is the server connected to the network. So the regular packets are dropped before they can reach the server. So there is actually no protection against UDP without changing network topology. Very dangerous is also TCP SYN flooding attack, but with an intrusion prevention system, it's easy to mitigate this attack. So the most dangerous attacks are flooding with register and option messages, and also TCP SYN attacks. UDP flood attack is also very dangerous, but BESIP itself cannot defend against it. So whole intrusion prevention mechanism is like a last line of defense on the server. You still need to have secure inner network, but if you don't have it, it's still better to have some security than no security at all. The SPT can be used for complex web testing, and important fact is that the part of the result is not only security risk warnings, but also precaution recommendation. And our future plans are mainly on improving intrusion prevention system, and we also want to run our own voice over IP honeypot, so we can get data about real attacks in IP infrastructure. In case of SPT, we want to bring some other modules, for example, for endpoint devices testing. And that's all. I thank you for your attention.
I have one question for you. You mentioned that you were using mostly open source tools, right?
Yes,
but did you test any of the commercial SIP servers, and sort of did they behave better or worse, or?
Yeah, there are also solutions which have modules for mitigating those attacks, but we want to bring a general defense mechanism that it don't depends on concrete SIP software PBX version.
Right.
It can work with
anything, yes. I was just wondering whether the behaviors you saw about, for instance, a high CPU load for register packets sort of made the whole system unusable, whether that was true for, say, like a Cisco call manager. They might have like a totally different code path for doing registrations, or like for YXA, which has yet another way of handling registration. So it might be interesting to compare different vendors and how they handle the attacks.
Yes, these are costly enterprise solution, and we bring a cheap solution for small offices, homes.
Right.
So you don't need those costly solution.
Yes. That's quite. So I think we have a question. Right?
Yeah. Hi. I heard there is a security problem in Skype that's both quite important and also quite hard to do anything against. That is, if you are, if I run Skype and whoever knows my Skype handle, which is the same as my Twitter handle, so I'm not keeping that a secret, then they can just call me and hang up, and they know and look at the IP address, and they know I'm in Iceland. And well, maybe it's not. There might be. I mean, that's it. I don't want to advertise where I am all the time through Skype. And is that same attack possible against SIP?
I don't know about this Skype attack, or I think
the way it works, because it's peer-to-peer. You're able to phone anybody. you phone them and you look at which IP address the traffic goes to, and you know which IP address this person is at because they're always reachable.
But isn't that only work? That only works if you're running a sort of public node, right? If your Skype has a public IP address, if you're at a place where you're not able to, if you're not publicly reachable on Skype, then you're probably meeting somebody at the supernode, right?
It's only whenever you have Skype running, but I usually have Skype running whenever I have my laptop open, and then people could make a graph of where I am each day of the year just by looking at my Skype. And I was just wondering, because it's the only way to announce where I am. I want people to reach me, and over IP they can see the IP address where they are reaching me. That's just how IP works. Is SIP also, or does SIP have something like Tor implemented where you obfuscate where the IP address of the other peer is?
I think it's possible to use SIP with Tor, and what I don't know anything about some implementation which use Tor defaultly.
So is it possible to see where someone is? Just because they're running SIP?
Yes, if the endpoint station has a IP public address, it's possible to know where it is.
Okay.
So it's a very long time since I looked at the protocols, but my memory is that SIP is only the signaling. So you'd only get the end station IP address if the audio channel was opened up. Because the signaling, you'll only see your local switch, I think. But
I don't know, maybe we can talk later about it.
Sounds like some people need to go and sort of paddle around some RFCs or something. Other questions? Okay. There are no more questions. I think we might end a little bit early. Go and see if there's coffee left outside or something, and then remember you have to walk to the Harpa today, so there are no buses to get to the gala dinner tonight. So it's very difficult to miss. It's the big pile of glass and steel down by the harbor. It's the biggest house on Iceland or something. So you get there under your own power tonight, and the gala dinner starts at 8. There's also a bar BOF on the Aspire project between 6 and 8, I think. So you can catch that if you're interested in the Aspire projects. Make sure to check out all of the nice posters, and thank you for coming.